So lesson 36 is critical numbers, and critical numbers, an important key part of calculus, really. Okay, if you look at the definition up there, it starts off talking about a critical number of a function x is a number c in the domain of f where either f prime of c equals 0 or f prime of c d and e. Meaning, so critical number happen when one of two things occur. Either when the derivative equals 0 or when the derivative does not exist. Okay, those are our critical numbers. Now, right here are some instances where the derivative does not exist. And in this absolute value v, right here at the point 0, okay, a derivative does not exist when you see a sharp point right there. So like I recognize this as absolute value of v. I know absolute value of v, or absolute value of x. I know there's going to be a spot here when x equals 0 that the derivative will not exist. And again, sharp points. So one of the things I will put here is no sharp points. So that'll be a good thing when looking at graphs. You can identify, okay, the derivative does not exist there. Same thing on b. I don't know if you guys recognize this graph, but this is supposed to be, at least I think it is, x to the 2/3, because it's that 1/3 graph and then feed up. I think there might be a stretch on it. So, oh, no, it's because it only goes to 1. So that's another point. And then this one right here, there's no sharp point, so you may be wondering, okay, how does it not exist? And this, by the way, is x to the 1/3. But this one is right here at 0. What's my graph do? If I find the derivative, remember derivative is slope of the tangent line, right? What's my tangent line going to look like at that point? It's going to be a vertical line right there. Well, what is the slope of a vertical line? If a vertical line is the slope does not exist, it's undefined or no slope. Okay, so when you have a vertical line, that's where slope does not exist. So right there is our third option. Okay, so those are ideas of where the slope does not exist. So sharp points or any place you would have to draw a vertical slope or vertical line, that would work. Next key point here. If f has a local or relative maximum or minimum at c, then c is a critical number of f. Okay, maxes and mins. You guys know maxes and mins, right? Are hills and valleys. What's a tangent line going to look like at a hill or a valley? Tangent line would be what? If I have this hill here, where's my tangent line go? Okay, it's going to go horizontal, yes? And what's the slope of a horizontal line? Slope of a horizontal line is 0. So vertical line is undefined, horizontal line is 0. So right there, anytime you have a max or a min, those are going to be critical numbers. Okay? So as we look at this graph for an example, you will see maxes, mins, but these are all what are going to turn out to be critical values. Okay? As you look at the dot at A, what do you know about the slope there? We have a sharp point, so the slope will not exist. So that derivative does not exist at that point. What about the dot at B? What kind of tangent line would I draw there? A horizontal. And when you draw a horizontal tangent line, what's the slope of a horizontal line? 0. So there's an example where my derivative is equal to 0. What about at C? What do you know about the derivative at C? Does not exist because it's a sharp point. Derivative at D, you would draw a horizontal line that has a slope of 0. Derivative at E, it would have a horizontal tangent line again, slope of 0. So those are all examples of critical values, critical points. Okay. A lot of our lesson now is about how we find the critical points. And I'm not talking about how do we find the critical points looking at a calculator, but given an equation. Because in case I haven't really mentioned it a whole lot, half of your AP test is non-calculator. Okay? So we can't rely on, okay, I'm just going to graph everything. I'm going to, we have to know how to do it without that. So example 1 here. Find the critical numbers of the function f of x equals x cubed plus 9 halves x squared plus 6x plus 5. Also find where the relative max and min values occur. So we're being asked for critical numbers, and then we're also being asked to find where the max and min values occur. So, any thoughts on how we go about finding critical numbers? When were critical values occurring? If you go up to the very top, when the, not 0 in for x, when do critical numbers happen? It's not when x is 0, it's when the, what's it say up top? When the f prime of c equals 0, so that represents the derivative. So when your derivative is 0 or does not exist. So in order to find critical values, we're going to have to find the derivative. Now, good news is, this is an easy thing to find a derivative of. So let me write my equation. F of x equals x cubed plus 9 halves x squared plus 6x plus 5. So, f prime of x. You got all your rules straight in your head? What is the derivative of x cubed? 3 out front, subtract 1 from the power of 3x squared. Plus, derivative of 9 halves x squared. Say what now? 9x. 2 times 9 halves is going to be 9. Keep the x, subtract 1, so now we're at x to the first. Derivative of 6x? Plus 6. Derivative of 5? Okay, 0. So now I have the derivative. If critical points happen where my derivative equals 0, what should I do? Set it equal to 0. So we're going to set 3x squared plus 9x plus 6 equal to 0. That will always be a step when trying to find critical values. I would. Because everything has a 3, this is going to be a lot easier to factor and solve is if I get rid of that 3. Because this is an equation that equals something on the other side, you don't even have to factor the 3 out. You can divide the 3 out, actually. So I can divide everybody by 3. And this works because it's an equation, not just an expression, but an equation. So if I divide everybody by 3, I now have x squared plus 3x plus 2 equals 0. Now how do I solve? Factor. 2 parentheses. X squared is x times x, multiplying to be 2 and adding to be 3. X plus 2, x plus 1. Are we okay with that? Okay. Now, what do I do to finish that off? Yeah, set each part equal to 0. X plus 2 equals 0. X plus 1 equals 0. And so we know x equals -1, -2. What are those I just found? Critical numbers. Yes? Okay, so that answers the first part of the question. Okay, these are the critical numbers. Again, critical numbers are easy to find. It's set the derivative equal to 0 and find those values. Now, it also wants to know where the relative max and min occurs. Well, the derivative equal to 0 means that when the derivative equals 0, those are going to be places where the derivative equals 0, so my tangent line is horizontal. My tangent line is horizontal, that's happening at either maxes or mins. So in order to find our max and min values, the max and min values are how high that max is and how low that min is. My max and min occur at -2 and -1. So we're going to want to plug these in. Now, before I do that, I want you to visualize something with me for a moment. Okay, what type of graph was this original graph? It's x to the third, it's cubic. What are my options for what this cubic graph might look like? In other words, again, I'm trying to get you to visualize this one like if you're not allowed to use a calculator. Okay, so it's x cubed. You know what an x cubed look like? It's a positive. So one option is it just goes like that, right? What's the other option? Yeah, it kind of has to do that up-down thing. If I have two critical numbers, which one do I have to be talking about in this case? My graph, when I graph it, is going to be some variation of that. Because there's going to be a max value right there, so my derivative is going to equal 0 there, and there's going to be a minimum value right there. And so my slope will equal 0 not once, but twice. Okay, so to actually find the critical numbers, plug them in. We plug -2 in. You're plugging into the original equation. So we want to know how high or low the graph goes. So that means I'm finding f of -2. -2 to the third plus 9/2 times -2 squared plus 6 times -2 plus 5. Can you do the math with me? -2 to the third. -8. Okay. -2 squared is 4 times 9/2. Well, 4 divided by 2 is 2. 2 times 9 is 18. 4 times 9 is 36. Divide that by 2 is 18. 6 times -2 minus 12 plus 5. So -8 plus 18 is 10. 10 minus 2 10 minus 12 is 2. -2 plus 5, 3. So we know in order to pair in our graph is -2, 3, yes? Is that a max or a min, do you think? How can we tell at this point? I haven't graphed it. I don't have my other critical point figured out yet. How can I tell that -2, 3 is a max?
It's a positive, and that's your farthest point.
Okay. Are you talking about the 3 being a positive?
No, it's a positive function. And,
Oh, okay.
The -2 is your farthest point.
Okay. So right here, if my critical numbers are at -2 and -1, one critical number is here, my max is here, my min is here. As you move left to right on this graph, which comes first, -2 or -1? -2 comes first, so this is going to be the max. Now, we can verify this in a moment, because when we do the other one, my other number, y value should work out to be lower. But that's how you can do this with just, thinking without actually graphing it. So now plug in the negative 1. Negative 1 cubed plus 9 halves times negative 1 squared plus 6 times negative 1 plus 5. Let's see. Negative 1 to the third. Negative 1. Negative 1 squared is 1 times 9 halves plus 9 halves. 6 times negative 1. Should be minus 6. I just wrote plus negative 6. Plus 5. It's a really big minus sign. That looks weird too. Sheesh. Okay. Have you finished up the math there? Me personally, I'm going to do whole numbers first if you don't mind. Negative 1 minus 6 is negative 7 plus 5 is negative 2. Negative 2 plus 9 halves. What is 9 halves? 4.5. So negative 2 plus 4.5? 2.5. So I actually have 2.5 written in my notes. 2.5. I don't care how you write it. So my ordered pair here is negative 1, comma 2.5. Is this a min or a max? A min. 2 ways I know it's a min. First of all, we already talked about the fact that negative 2 comes first, it's the max. Negative 1 comes next, it's the min. The other thing is, look, a y value of 3 is higher than a y value of 2.5. So 3 would need to be a max, 2.5 would need to be a min. And that's based on the fact that these are both critical points. So it took me a moment, but mathematically I don't think critical points are hard. Okay, it takes a little work at the beginning as you get them figured out. We do a lot harder stuff, I feel like. So, questions? Try another then? Okay, let's do it. Find the critical numbers of the function f of x equals 1/4 x to the fourth minus 1/3 x cubed minus x squared plus 5. And indicate where the relative max min values occur. So, what's the first thing we find? Yeah, critical numbers means I need to find the derivative. So let me write my equation down. F of x equals 1/4 x to the fourth minus 1/3 x cubed minus x squared plus 5. Derivative?
X to the third minus x squared minus x plus 5.
I was good with the first two.
And it's minus 2x.
Bring the 2 out front. Minus 2x, you're subtracting 1 to the power. Derivative of 5? 0. Are we okay with the derivative? What do I do with that derivative? Technically, before I factor, can I do one thing, please? I'm factoring GCF, same idea. What are we actually doing? We're going to set it equal to 0. Okay, so I want you thinking about, okay, I'm setting this equal to 0. Yes, and I guess you can always do that after you factor, but. So, first step here, after you set equal to 0 is factoring, and I heard GCF. There's a GCF of x. So then I have x squared minus x minus 2. Okay, so it factors farther is what you're saying? X squared is x times x. 1 and 2. To get a negative, I need opposite signs. Large number negative. So x plus 1, x minus 2 is what I wrote. What's next?
X equals 0 to the negative 1.
Okay. So officially, set each part equal to 0. And I know some of you guys are doing this in your head. Although keep in mind, show some basic steps here. What are my pieces? 0, negative 1, and 2. Okay, what are these guys? These are your critical numbers. Okay. What is plugging them back in for me going to do? Yeah, give you your y values to go with them. And so then you will actually have the max min. Now, because I want to test your graphing brains here. What kind of graph is this originally? It was x to the 4th. So, can you visualize with me what some quartic options might look like? What's an x to the 4th graph look like?
W.
Okay. One option is a W. What's the option before that? Okay. Officially, that's a basic quartic, right? Okay, it's not going to work here. We'll talk about that. But then the other options are your W. Whether it's an symmetric W or whether it's a lopsided W. Okay. And I guess why did I draw both ends going up? Because it's a positive x to the 4th term, right? So those are your quartic options. Now, we know we have 3 critical numbers, right? So that means our slope has to equal 0 3 times. In which of these does my slope equal 0 3 times? Well, really, any of them except the first. If we only had one critical value, then this first would be the way to go, because there's one minimum. But we need, if there's 3 critical values, we need some combo of 3 mins and maxes. These all offer 3 mins and maxes, right? Okay, where are we at on time? Okay. Based on my notes, what I've done in the past is we can go the calculator route if you want, or I can even just tell you. But you guys know we are going to plug these in. So that means I need to find, and I'm going to go left to right if you don't mind. So when I say left to right, that means I'm first plugging in negative 1, then I'll plug in 0, and then I'll plug in 2. Okay. You want to do it or you want me to tell you? I'm not against telling you at this point. I mean, it's a matter of knowing how to use your calculator, knowing how to do the math. But if you plug in negative 1, I first of all have it written as 55/12. But if you look at that in terms of something to think about mins or maxes, that goes what? 4 times and what? 7 extra? So this is the ordered pair negative 1, comma, 4 and 7/12. Based on my quartic options, is this a min or a max? It's a min, yes? Because in a quartic, your first critical value is going to be a min. I'll let you guys do the next one. What do you get when you plug in 0? 5. So that is the ordered pair 0, 5. What's 0, 5 have to be? a max because it's the middle critical value as I work left to right. And when you plug in 2, I have 7/3. So that is the ordered pair 2, comma, 2 1/3. And what's that have to be looking at our graphs? That's a min.
It's the left sided with the
Okay, so yeah, if you are trying to figure out which, here's the idea. The y value in the max has to be the highest y value out of all these, right? Otherwise, we've done something wrong. Okay. Other than that, okay, based on the fact that this one is a little bit lower than the lopsided right value will work. Did anyone graph this? I better use. I'm going to show you what it looks like real quick so you can have a little. Okay. Do you see the W form? It's there, isn't it? Okay. It's there. You can kind of see, min, max, min. And even if you wanted to check one of your mins or maxes, it should agree with what we found. But again, I'm also trying to train you guys. We can't always just jump to that calculator as much as we want to. Okay. Last example. And this is just kind of a side note here. We'll come back and talk to this more when we talk later about critical numbers. But notice what it says. Not every critical number produces a local max or a minimum. Okay. For example, f of x equals x cubed. Find the critical values and check to see if it is a max or min. Well, okay, if it is just f of x equals x cubed, if we follow that same process, you first of all take the derivative. Derivative of x cubed is 3x squared. Set the derivative equal to 0. When you solve that for x, what do you get? 0, because you're going to divide by 3, and then you're going to square root it, and the square root of 0 is 0. So x equals 0 is my critical number. Well, think about this. X cubed, what's x cubed look like? That's our basic squiggle there, right? Where is x equals 0? It's right there. And I think I threw the word inflection point out to you previously. Okay. So, we'll talk about that more later. And what that does, that inflection point, is actually it changes concavity. Okay. So it's not a min or a max. It's an inflection point. It's still a critical value, though. Okay. So you do have those weird instances where it doesn't turn into a min or a max. They often do, just not always. So I'm going to say not a min or max. If you're thinking ahead, this is an inflection point. Now, the basics of what we're doing today, what are they going to turn out to be? Mins and maxes. Okay. Got it?